So today I'll be discussing about the importance of embedded system in agriculture for pest detection. Uh, so an embedded system is a computer system which is designed to perform specific tasks within a large system. So in a detection system, they are often used to automate the process of detecting and monitoring the pests in agriculture fields and in other environments. So the system typically consists of a hardware and software. So in the software part, the AI, the importance of AI comes into the view. So nowadays, every system in the world is trying to integrate artificial intelligence AI into the system. So which classifies the works easily and which does the works easily with the help of certain algorithms which are integrated into it. So in this system we can use these certain type of algorithms to uh, predict and classify the pests which are detected by it. So as I said earlier, the embedded system can be simply defined as a computer system which has a processor, memory, input and output peripherals. So the examples are shown below. These are not really the embedded system. These are development modes which are integrated for us to do some specific task for a specific period of time, I would say. So with the help of these development modes, we can do this. We can integrate the artificial intelligence into it, and also due to the certain algorithms presented, we can classify and predict the pests and the diseases caused by it. So basically, we what we are planning to do, or what we need is a system that can be integrated in such a low cost that can be affordable by most of the farmers or anyone. So the product or the system need to be more affordable. So if only if it's affordable, we can use this as a daily use. We can use this in daily use. So the system need to be affordable. For such a system, I think there are three major components which we need to focus. So it includes an image sensor, which captures the image, uh, quite quite uh, in a clear manner and send this into a system for the next process. So the second, it include a microcontroller system. For example, I have included the Raspberry Pi here. So the Raspberry Pi is used, and the Pi is used for the pre-processing, which I will tell you later what includes in pre-processing and all the other stuffs includes in this. So it includes a pre-processing stage, and it's done by the microcontroller system. In the pre-processing stage, most of the classification is done in this state. In this state, so the pre-processing would be so much. The pre-processing is a very important stage here. So as the next stage, the pre-process data from the microcontroller is directly fed into the component called the neural compute stick. I would say the neural compute stick is solely responsible for the prediction process which is involved in the pest detection, uh, which is also a major and important part. of the system. So the pre-processing of the data and the prediction of the pre-processed data. Prediction include certain algorithms, going through certain algorithms and analyzing it through certain algorithms exact for the exact results uh, with a pinpoint accuracy, I would say. Uh, so for this we use certain we for this we use certain deep neural network algorithms which are solely available uh, to us in this world. So with the use of this algorithm, we can predict certain behavior and certain behavior, and we can use these algorithms to predict predict and classify images from a real-time input. So after this classification, the final data is transferred to the user for further process. So as I said earlier, the image sensor is a major component in this system. So the image sensor is integrated in this system uh, to capture the images of pest and or insects. So it has it simply uh, it simply has given us an integrated module with the system. So uh, it, without this module, we cannot do any further processes which are involved in this. So as a next step, the image captured by the image sensor is then transferred to the microprocessor for further pre-processing. The microcontroller system is also an important module in this. So the pre-processing stage is done by the microcontroller system, and also the pre-processing stage includes the following uh, steps, which are the following five steps for the which include the picture windowing, the smoothing, and the edge extraction, ROI thresholding. ROI means region of interest, and ROI selection. These are the major steps which includes in the pre-processing stage. So the pre-processing stage, which simply converts the picture taken by the image sensor and uh, uh, apply uh, or with the help of some sufficient filters, which converts this taken picture into a data which can be transcribed, or which can be uh, read by the microcontroller, or the which can be used for further process, like the to which can be used to read by the algorithms in the deep learning network systems. Now the data after the pre-processing is directly fed into the neural compute stick. So the neural compute stick can be defined as a component which can be used to ease out the machine learning tasks of a system. As we previously discussed, we use Raspberry Pi there, because we can say that the Raspberry Pi has a small processor which has certain limitations of its own. So handling big tasks like adding machine learning or any artificial intelligence algorithms to the system will be congested by after adding this. So it will take more time for certain prediction and to give certain results. To ease out this, we use the neural compute stick. So Intel NCS2 and NVIDIA Jetson Nano and Google Coral USB TPU. There are various examples of compute sticks. So the compute sticks are certain a small system which has dedicated cores and neural compute engine. So it provides the hardware acceleration for certain deep neural network interfaces. So with the help of these with the help of this we can easily classify easily do the classification algorithm in this. So by using this it would take much less time than what we do in the Raspberry Pi. So this slide shows the total workflow of the system. So when the system the first system boots up, so it continuously takes the picture using the image sensor which is integrated into it. So we can also call this also a real-time system which takes the real-time input values and gives the output based on it. So when the image, so first the image sensor takes the image and it gives it to the microcontroller for the ROI extraction. It simply means the pre-processing stage, which includes the picture windowing, smoothing, edge extraction, and ROI thresholding and ROI selection processes. So after these processes are done, the the output data from these is directly fed into the neural compute stick for the classification process. So so in this the for the classification process, so the data uh, after the pre-processing stage is directly fed into the neural compute stick. So this data is continuously analyzed with the help of certain algorithms in deep neural networks such as CNN, and also we can use all other algorithms which can classify and predict the results based upon real-time images. So after this classification, the final analyzed data is given to the user as a report. So after giving this report, the system will turn off automatically and wait for the next user action. So this shows the total workflow of a system uh, from boot to sleep. So this includes this say the whole processes which is done by the system uh, in this life cycle. So from these slides I would like to say how the image classification process is done in the neural compute stick. So in recent times the convolution neural network has become one of the strongest proponents in the deep learning. So the convolution, so it's being said that the convolution neural network has been mostly or widely used in case of real-time image classification and real-time process. It says that the most popular application of the convolution networks is image classification. So the convolution neural network is mostly and widely used for the image classification. So For our process, the real time image classification, the mostly welcome than the ideal algorithm will be the CNN. For our application, the neural compute stick is attached to a system and uses the help of convolution neural network technology for the further image classification. So, in this, the input data is fed through sorry, several layers of like convolution layer, pooling layer, and fully connected layer. So, the data is continuously transferred or fed through these layers. For these layers act as filters for certain things, so the data is continuously fed through this layer. So it so the continuous action so this continuous action helps in creating more and more accuracy to the results. And so if we come more deep into the convolution neural network, as I said earlier, the convolution neural network is composed of various convolution and pooling layers, which ends with a fully connected layer. So the CNN has mainly major three layers. So it's firstly is a convolution layer, then the pooling layer, then there's a small subsampling layer and a fully connected layer. So the figure here in the slide shows the whole CNN process for a with, with a limited number of layers. So the input the input is directly passed to a convolution layer. So the input image is passed through a series of convolution layers. So each layer consists of multiple filters which are applied to different regions of the input image to extract the features. So the extraction of features is done here. So each filter produces a map that highlights a specific aspects of the input image. Each filter highlights a specific aspect. So there are so many convolution layers needed for the to process an entire image. So in this image, this only shows two convolution layers. So in a real-time system, there are so many convolution layers used uh, to uh, to specify the highlights of an input image. And these after the convolution, this uh, data is transferred to a pooling layer. So which the pooling layer simply reduces the size of the feature maps by downsampling them. So this mainly helps to reduce the number of parameters in the network to prevent overfitting. So the pooling layers converts the data uh, which downsamples the data which can be uh, further used, or which can be further used for some processes. So as the final output, we get a reduced datasets which uh, so with the help of these datasets we can predict the possible outcomes of the possible outcomes of the possible outcomes. So, as a conclusion, I would like to say that the system provide computer vision solution for the automated pest detection. So, this could be a completely automated system which captures the image and pre-process it and classifies it, and gives certain output based on it. So the system exploit the machine learning functionalities on it to evaluate the captured image and to classify the pest accordingly. So the system uses a certainly new technology for us, I would say, but it uses these advanced technologies for the future prediction and also for the betterment in the agriculture sector.